Distributed consensus. Today main agenda is we'll see definition of distributed consensus, how to identify malicious node, then we will see types of consensus like Bitcoin consensus and we will see other consensus followed by consensus without identity. The first application of blockchain is Bitcoin. Here we will see the problems and challenges of distributed consensus. Then we will see the futures of consensus and application of consensus. Let's begin with the distributed consensus. Before understanding consensus, let's look at on centralized system. If any centralized system like a database holding keys information about voter ID card in a country, a central administrator has authority to maintain and update the database. The task of maintaining any update like adding, deleting, updating names of people who qualified for certain voting eligibility is performed by a central authority called government who remains the sole in charge of maintaining genuine record. Public blockchain that operate as a decentralized, self-regulated system works on a global scale without any single authority. They involve contribution from hundreds of thousands of participants who work on verification and authentication of transactions occurring on the blockchain and on the block mining activities. In such a dynamic changing status of blockchain, this publicity shared ledger need an efficient, fair, real-time, functional, reliable, and secure mechanism to ensure that all the transactions occur on the network are genuine and all the participants agreed on a consensus on the state of ledger. This all-important task is performed by the consensus mechanism, which is a set of rules that decide on the legitimacy of contribution made by the various participants called node of the blockchain. By the definition of distributed consensus is a procedure to reach a common agreement in a distributed or decentralized multi-agent platform. It's important for the message system. In distributed consensus, all the nodes are connected in a peer-to-peer network to identify intruder node or malicious node in a blockchain network. It has a set of protocols or we can call rules and making a common agreement while joining in a mining. There are some conditions that need to be followed in order to achieve distributed consensus. Termination. Every non-faulty process must eventually decided. Agreement. The final decision of every non-faulty process must be identical. Validity. Every non-faulty process must begin and ends with the same value. Integrity. Every correct individual decide at most one value and the decision value must be proposed by some individual. Here one validation criteria. So basically, we should reach a decision which a value that must be initially value of some process because it is silly to reach an agreement when the agreed value reflects nobody initialized choice. Next, we will see how to identify malicious or faulty node. Step 1. A number of processes in a network decide to elect a leader. Step 2. Each process begins with a bid for leadership. Step 3. In traditional or conversational distributed system, we apply consensus to ensure reliability and fault tolerance. It means in a decentralized environment, when you have a multiple individual parties and they can make their own decision, then it may happen that some node or some parties we are working malicious or working as a faulty individual and identify them. Then step 4 is so in this such case, it's important to come to a decision or making a point of view if any node not following any protocol and making their own protocol and creating a faulty network and all nodes coming to decide this node going to malicious. Hence, we have to abort or terminate malicious node in this network. Disadvantage of malicious or faulty nodes, people can crash the work in a faulty way is the main difficult. In the step 5, this kind of distributed environment, our objective is ensure reliability, which means to ensure correct operation in the presence of faulty individual. And then next we will see types of consensus. The blockchain consensus mechanism, there are different kinds of consensus mechanism algorithm, each of which work on different principles. The first one is proof of work. It's a common consensus algorithm used by the most popular cryptocurrency network like Bitcoin and Litecoin. It's required a particular node to prove that the work done and submit by them qualifies them and receive the right to add new transaction to the blockchain. However, this all mining mechanism of Bitcoin need high energy consumption and longer processing time. And next consensus is proof of stake is another common consensus algorithm that involves as a low cost, low energy consumption alternate to the proof of algorithm. It's involve allocation of responsibility in maintaining the public ledger to a particular node in proportion to the number of virtual currency tokens held by it. However, this comes with a drawback that incentivize crypto coin hard coin instead of spending. Next, we will see that proof of capacity. Before that one, POW or proof of work and proof of stake are by the far the most prevalent in the blockchain space. There are other consensus we will see about proof of capacity, which allows sharing of memory space of contributing nodes on the blockchain network. The more money or hard disk space a node has, the more rights to grant and maintaining the public ledger. The proof of activity is used on a decreed blockchain is a hybrid that makes use aspect of both proof of work and proof of stake. Next consensus is proof of burn is another required transaction to spend small amount of cryptocurrency to inaccessible wallet address, in effect burning them out of existence. Another one we will see proof of history developed by the Solana project. Its aim to lighten the load of the network node is processing the block by providing a mean of encoding time itself into the blockchain. It solves the time challenge and thus reduces the processing weight of the blockchain, making it lighter and faster. And one more familiar is proof of elapsed time. Encode the passing of time itself cryptographically to achieve consensus without expending many resources. Proof of elapsed time consensus mechanism algorithm prevents higher resource utilization and high energy consumption and keeps the process more efficient. We listed a basic consensus protocol and is detailed if you want to go through cryptocurrency and consensus protocol. Through this figure, you will get a lot of consensus and based upon the consensus, which type of cryptocurrency is made. Consensus without identity, the application of blockchain is Bitcoin. There are a couple of reasons why Bitcoin node does not have identities. A Bitcoin protocol is a peer-to-peer decentralized system, so there is a no central authority that assign identity to node and verify that they are not creating new nodes. This could like a Sybil attack. Malicious node could create a lot of copies of node all controlled by them look like there are a lot of different participants. When in fact, all those pseudo participants are really controlled by the same adversary. Pseudo anonymity is a good goal of Bitcoin, so it does not assign an immutable identity, even if it could be possible. Also, in distributed system, a Bitcoin does not provide a strong anonymity, since different transactions of the same subject can probably link together, but at the same time, it's not necessary to use a real identity to take part to the network. So an advisory could trace the transaction and correct them to an address, but it could be harder to understand who is really making them transaction. Why consensus algorithm works? Let's see how can a malicious adversary try to subvert this process. Take an example. If an Alice is a malicious attacker, he could try to steal bitcoins belonging to another user. He is not able to do this because he cannot forge someone else's signature. Hacked against another user called Bob. For example, Alice could try to insert any Bob's transaction into new block, but there will be other honest node that will be gathered Bob's transaction into new block. Trying to spend some coins twice called double spending attack. Problems and challenges of distributed consensus. The first problem is cache fault. Let's consider cache faults. A crash fault is a distributed network, often may be related to one of the following issues. Node or replicant may experience downtime at any time, stop running for a short time and recover later. The network may be interrupted at any time. A message sent may lost during delivery and cannot be received. Messages may be experienced out of order problem during the delivery process. The network may be divided, for example, due to pure collection or communication. Between the cluster in China and the US, the entire network may be divided into two subnetworks for the China cluster and US cluster for an instance. The above problem or common distributed system, they are essentially the inevitable risk caused by the unreliable and unstable physically hardware in a distributed system. Example, a network or communication channel cannot always be stable and reliable. A disk on a physical machine or CPU will not always be good condition. Therefore, it is safe to say that crash faults are the most basic and common type of faults to be solved in distributed system. The next problem is the Byzantine fault. The crash faults are based on the simple assumption that the nodes do not work or respond normally, or although they work and respond normally, they cannot implement inconsistency. That is to say, being ideal is okay for them, but they cannot commit some errors. Malicious node in network may changes and forgive data at any time, making it hard to solve the consensus problem. This troublemaking problem that may changes and forgive data or response information are often referred Byzantine's fault. The crash fault is called as a non-Byzantine fault. And next one is a fault tolerance. The most critical problem that distributed consensus algorithm need to solve in question of how to implement certain and consensus. So the reliable consensus results are written across the entire distributed network, which can be full of risk and uncertainties. Naturally, it is a relatively easy to solve a crash fault. Algorithms used to solve this type of fault are called as crash fault tolerance algorithm or non-Byzantine fault tolerance algorithm. A Byzantine faults may cause unauthorized chance, having higher complexity and are more difficult to solve. Algorithms for solving this problem are called Byzantine fault tolerance algorithm, which is a boundary between the two types of fault tolerance algorithm. In this scenario, two types of fault occurrence. It's real necessary to take an unauthorized changes into the consideration. The next one is the crash fault tolerance. Generally, if a system is in reliable internet network, we only need to consider the issue of crash fault tolerance. For example, for distributed components, in many companies such as distributed storage, message queue, and distributed services, we only need to consider CFT, nothing but crash fault tolerance. The reason for this as follows. The entire enterprise network is closed and protected by the multiple firewalls, making external access and attack unlikely. Individual nodes are deployed in a unified manner, and it's very unlikely that machines and running software gets changed without proper authorization. The distributed network is relatively pure at this point, and we only need a pay a special attention to communication network and machine hardware. We need to consider network latency and instability as well as downtime and fault that machine may experience at any time. And next one is a Byzantine fault tolerance related to the entire distributed network. Being evaluated a large environment in a physical hardware, it is also necessary to take some man-made factors. After all, the specification person instead of machine that perform misconduct. Assume that a distributed network is relatively open. A private network of 10 of companies in a specific industry. Or assume a complete open network, a network that anyone has access to. The node mission software on this mission are deployed by individual companies or individual themselves. If the benefit is tempting enough, a person may launch DDoS attack on one of these nodes, making authorized or fun malicious changes to software code and to the code executed logic or even the data in the persist on the disk in the network. In such cases, we face a bigger challenges. In addition to unreliability communication network and machine hardware, we need to consider deal with a troublemaker in the system. Let's look at the features of Byzantine. It ensures reliability and fault tolerance in distributed system. In presence of a faulty individual, it ensures correct operation. Application of a distributed consensus or a leader election in a fault tolerance environment for initiating some global action without introducing a single point of failure. A maintenance consistency in a distributed network. Suppose you have a different nodes monitoring the same environment. If one of the node crashes, a consensus protocol ensures robustness against such a fault. This and video helping to how the consensus will help you and what are the distributed consensus, what the types of consensus are available. And here in this video, we are given a brief explanation of Bitcoin consensus called proof of work, how the miners are going to use a power consumption and solving a mathematical puzzle. That's it. Thank you.